Hello everybody and welcome to another mystery box function challenge. In the purple box there is some mystery math and your challenge is to figure out what it is. You can use the link in the description if you want to try this out on your own, and when you've got an idea come on back and see if we get the same thing. Alright, I'm going to start with a 0. Okay, 0 gives us 2. How about a 1? Okay, so we've got 3 and that looks like a non-repeating decimal. So maybe this is square root, maybe this is trig. Those would be two likely candidates. Let's look at a 2. So we went up and now down. So now I'm starting to think more trig. How about a 3? I see it. And actually, let's put in an approximation for pi here. So 3.14. Aha. So we're basically at -2 at pi, and we're at 2 at 0. So that's a clue. Let's get a few more points in here. Let's go for 4. And 5. Okay, we're way up there again. So it's a little hard to see. I'm going to try pi over 2. So let's put an approximation for that. So 1.6. Yeah, we've got a very large negative number at pi over 2. So I think what we've got going on here is actually one of these inverse trig functions, the secant or the cosecant, because you can see that we have, well, actually, let's do a couple negative values. I'm going to put in -1/2. Maybe you'll be able to see the curve better. And a -1. Let's put in a +1/2. Yeah, so now you can see the shape of this curve here around the y-axis, and then we've got a curve down here, and then this is part of another curve up here. So what I think we've got here is actually the secant, and the reason I say that is because at 0 this function is defined, and at 0 the cosine, so our point here is 1, 0, the cosine is the x, so the cosine is 1 at 0. So the secant is 1 over the cosine. That's the secant, and this is what I think it is. And so this is defined at 0 because you get out a 1. The cosine of 1 is just 1. So this should be 1. This is actually 2, so something else is going on here. And this is -2 down here. Yeah, I think probably the easiest way to fix that is just multiply the whole thing by 2. It wouldn't be adding 2. No, it wouldn't be adding 2 because then the whole graph will get shifted up. So I think you have to multiply by 2. Okay, so 2 over the cosine of x, or 2 times the secant of x. That would be the same thing. So let's think about the values we're getting here and how this would match. So at 0, the cosine of 0 is 1. So you'd get 2 over 1. And we're getting 2. At pi over here, the value of the cosine, this is the point -1, 0, the value of the cosine is -1, so it would be 2 over -1. That's a -2, and that is what we're getting, -2 at 3.14. At pi over 2, we've got this number that's rapidly approaching -infinity here. That's because at pi over 2, the function is not defined. So here's pi over 2. The coordinate here is 0, 1, so the cosine of pi over 2 is 0, so you'd have 2 over 0, and that would be undefined. So I think that's what it is. I think we've got 2 times the secant of x, and I'm willing to take a look here. Yeah, 2 times the secant of x. Let's go ahead and graph that. So you've got those same sort of U-shaped curves that repeat alternating in the positives and the negatives that we saw for the secant or for the cosecant. Because we've got that multiplier of 2, it's going to start at a +2, the positive ones, and it started at a -2 down below on the negative ones. Well, how did that go for you? Were you thinking these inverse trig functions? Let me know. Thanks, everybody.